Today we're going to be looking at the accuracy of 3D printing, and we're looking at the Bravura Trumpet. We are going to talk about the accuracy and consistency and strength of both the nylon and the stainless steel. And what I'm holding right here is the Bravura Trumpet. It may look bulky and heavy, but it's actually fairly light. This one has the tracking and all the extra stuff on it, and it's probably a couple ounces heavier than a Bach or a Yamaha. So not the lightest trumpet, but definitely not very heavy. And if you were to compare, say, a lightweight Bach to a standard Bach, it's typically about 1 ounce in difference. So there's not a huge difference there in the first place. But compared to our third generation Summit, this is more than a pound lighter. Compared to the Muse, it's even more, lighter than that. It's a lot lighter than that. So I want you to know, first off, that the reason I chose nylon for this was because it really was the best material available today that is cost effective. I could choose titanium, right? But then we wouldn't be able to offer the Bravura at the price point we do, which is lower than a professional Bach or Yamaha. And we're not even talking the artist models. The Bravura is just really well priced. And for something that's made right here in the United States, that's a pretty big deal. But we chose nylon primarily because it has all the right characteristics. And we chose stainless steel for the lead pipe for the exact same reasons. It would cost me more to draw lead pipes in brass and do all the work we have to make this system work than it would to actually do it in stainless steel if I want those weight savings and I want that improved efficiency. In other words, the amount of energy I put in and the amount of sound I get out. So that's really, really important. When you're looking at the science of sound and how to get the most out of an instrument, we really want that lead pipe to be something that is not going to move from energy in the sound wave. So I want to show you first some of the sample parts. Well, actually, these are the real production parts for the Bravura, and show you up close what kind of accuracy we're looking at. One of the things that I was really concerned about maybe 10 years ago in 3D printing was that it would never become accurate enough to do my kind of work, to build trumpets or the other things I do. I always looked at it as kind of maybe a little bit like a gimmick, but also like a tool for just limited applications. And for years we had 3D printers that we would use just to print fixtures and storage containers for special parts. So for instance, when we build trumpets for the last 10 or so years, we actually take all the pistons and we put them in special sleeves that are 3D printed, and then it all goes in a special case and there's a spot for every single little piece. We've done that for over a decade. And all those containers that held all of our parts as they moved around the shop in the different work areas with different people working on different parts, those were all 3D printed. And I saw 3D printing as that's what it's going to be for us. It's not going to be, it's not going to go any further than that. But I was wrong. And I told my team, I said, I don't think 3D printing is ever going to go anywhere. In fact, we had someone who had spent like $5,000 or $6,000 having all kinds of parts 3D printed to try to build a 3D printed trumpet many years ago, maybe probably around 10 or 11 years ago. And this person, I don't remember his name, but he came to the shop, he scheduled a time. He says, I'm going to talk to you, and I'm talking to Dave Monette, and I think he talked to one other maker about selling all of his research into 3D printing trumpets and valve casings and all kinds of things. And he came in and he brought this box of stuff, and it was all pretty bulky and heavy 3D printed metal stuff. And he had tried to print a piston and a valve casing and some other parts. I don't remember exactly what was in there, but a bunch of parts that were more critical, difficult parts to make. And he showed me these parts and he said, look, I'd like to sell you everything I've done for the price I paid to have it all printed, and give you all the information I've learned from it. So he was trying to recoup his investment because he had given up on it, and he thought maybe I could use this. And I looked at everything he had and I considered it, and everything was so crude. Like the prints were so poorly done. And I thought, I'm gonna have to remachine every piece of everything that was printed. Why not just machine it the way we do already, machine it from scratch? If I want to make a piston or a valve casing in-house, then I can just run it on the twin spindle lathe right there, and I can make the casings and I can make the pistons and I can fit all that and do it myself if that's how I want to do it. And machining is a faster, easier way than 3D printing and then remachining it. And I'm telling you all this because times have changed. Times have changed a lot. When I saw that box and I looked at all the parts, I probably have a photo of it somewhere, I thought to myself, there's no way we can make this work. And I told him, I said, I'm sorry, but I don't think it's worth my time to invest in this. And maybe Dave Monette or somebody else will want it. He'd already planned a scheduled visit with him. Maybe somebody else would want it, but I just didn't see the potential. And the funny thing is, additive manufacturing, which is called AM, and you call it 3D printing, most people call it that, but additive manufacturing has been around for like 50 years. And the companies that invented it and the universities that studied it in the beginning became the leaders in the industry. And most of the stuff that was 3D printed either didn't have to fit real tight tolerances or meet any kind of real tight surface quality finish tolerances, or it was used in areas where that didn't matter. And there are a lot of things that can be made where that doesn't matter, or maybe you remachine a few things like some special holes or a mating surface. That kind of thing is popular in metal printing, and then using it in a serious application like say an F1 race car, or on a satellite or a missile, or anything in aerospace, whatever it might be. So the reality is, I've always been going to the machine tool shows, and I've kept in close contact with my colleagues and the vendors and the companies that build different types of machines for CNC machining, which is CNC is just the computer numeric controlled machining. And the reason I stayed with that was because that's the direction we went. Instead of hand fabricating everything, we went almost entirely CNC. All the way through our third generation of the Summit, almost everything on that horn was CNC machined. And that was really cool. We had some massive advantages in doing that. And at the end of the day, we built a much better trumpet, much easier to play. I know a lot of people question the physics involved in designing our trumpets, but these are things that are reproducible, and you can certainly test them in your own if you have a lab, and if you want to even design trumpets and learn how standing wave efficiency principles work. I've shared that publicly. I'll share it again if you have questions. Anybody can do this. Just because we applied it to trumpet doesn't mean that there's some secret voodoo about it. It's all public. And we took the technology from aerospace and from transmission theory. So we got that, all the principles from what we do in trumpets, standing wave efficiency, from basically a bunch of research that was done on transmission theory. And I'm talking transmission in terms of sound waves, radio waves, transmission waves that are used for all kinds of things, everything from cell phones to satellites to military applications. And most of the early research for the first 30, 40 years was actually military. So we took a lot of those principles and we put them right into the trumpet. And then a lot of the other pieces came from aerospace, which was actually just basically regular physics that you would learn in high school and college. Because the idea is that in your instrument, you don't want the standing wave where there's a high amplitude section, where there's an antinode. You don't want that section to basically take the energy wave, the sound wave, and put that energy into the tubing and vibrate it. So you don't want that transfer of energy. That's where the transmission theory comes in. So let's say that I had a standard lead pipe, or even just the bell here, and I have an antinode that lands here. And I'll back up a second. Nodes and antinodes are what happens when you play each partial as you go higher on the trumpet. So a lot of people dismiss this as some kind of voodoo, and they say, oh man, Harrelson, he's just a con man. He made up all this crazy science to sell trumpets. Well, if it didn't work, I wouldn't have hundreds of the very best trumpet players in the world on our instruments, and we do. And I rarely say that, but the truth is we have many of the very best trumpet players on our instruments. Most of them are in jazz, and I would say the reason they're in jazz or other settings than classical is because the classical world is unfortunately too stuffy and too conservative to open their eyes to new technologies. And that's just the way it is. Sorry guys, I'm not trying to write you off, but you know as well as I do that if you bring in something that's slightly different, everyone's going to criticize you and judge with their eyes and not with their ears. And we've seen that again and again. And Monet had his rise and fall in classical music as well. I've had it. I've had lots of orchestral players play on our horns, and then eventually they didn't want to deal with the criticism anymore. And it's unfortunate that we have to have those old world views, and we can't just be open-minded to technology. And it's not even new technology. It's just applied in a different way. But all that to say, we have a standing wave inside the instrument, and this science is proven, it's real, and you can actually test it yourself. When the standing wave is just the fundamental, you're playing the lowest note of the instrument, then there's one antinode in the middle of the instrument, wherever that might be. It's probably right here on the valve casing on most trumpets. Now, as you play the next partial up, you get two antinodes, or you get two nodes, you get another antinode, and every time you play another partial, you get another antinode. And eventually you stack up 10, 12, 14 antinodes, and they start to evenly disperse throughout the instrument. Every time you play another one, they spread out a little, or they get a little closer together. So they move. And if we have an antinode that's, say, right here compared to right here, then this section has a little bit of bracing on it, actually a pretty beefy brace. But on a standard trumpet, there'd be a little brace there. If the antinode lands there, then the tubing wall is not going to set into motion from the transfer of energy at the high pressure zone of the antinode as easily as if it were somewhere where there isn't a brace. Now, all that to say that that's how simple it is. That's how simple standing wave efficiency is. Now, we've taken it a long ways. We've researched it for decades, and we understand a pretty good idea of where you can and cannot do that. And we know that we want the bell to resonate as much as possible. So we try not to put braces up here because we want more resonance. And that's why Harrelson trumpets have more resonance than other professional trumpets. All that to say that at the end of the day, you want the energy to not transfer into vibration except at the bell. And that is extremely important. If you don't do that, you don't have this effect of the energy efficiency changes. Essentially, we want to conserve the amount of energy that's inside the horn so it can be released in the bell. And when it comes to the stainless steel lead pipe, the reason we chose that is because we wanted to be able to make this stiffer and less likely to let that energy transfer into vibration, and it doesn't because it's so stiff. So that's the first thing I want to show you is the lead pipes. And I've got 3 generations of lead pipes that I've printed here. Of course, I've made dozens of generations of lead pipes over the years, but in stainless steel, this is what they look like. And I'll hold it up to the camera close here in just a second. But the breakthroughs in the technology and 3D printing have been massive in the last 20 years. And those prints that I saw from that guy who brought them in 10 years ago, they were really, really rough. They didn't look usable, and I didn't think we could do anything with them. But what I've discovered, having spent tens of thousands of dollars having companies print things for me, is that it really, really does matter which machine it's printed on, because some of these machines are much better than others, and it matters which orientation it's printed. It also matters who programs all of that. So whoever decides, hey, this is how we're going to print it. Because you can print in really thin, fine layers, or you can print in really deep layers. And if you do that, if you have real thick layers, you're not going to have the accuracy. If you print at the wrong angle, you're going to have supports and other issues. You might have something sag or warp. And all of that is, it's kind of an art, and there's obviously a lot of science to it as well. But the only way to really get good at this is to own the machine and have it right there in your shop and get good at it. And that's what we're trying to pursue right now. We want to get the 3D printing of the steel in-house. And to do that, we're looking at like $1 million machine. And that's why we don't have it right now, because we're not a huge company. We're a small custom trumpet company. There's only 3 of us here. We've never been rich people. We've just always been head deep in, or neck deep into research and development and solving problems and helping individuals. So we've never mass marketed anything where we're going to sell thousands of this or that. We've always been the custom solution. And when you do that kind of work, you do it because you have a passion for it, because you love it, and because you love the people you work with. Unfortunately, that also means you're going to have a bad rap with most people, because unless you've had that custom experience, it's easy to write off these new things that look different or that you criticize and say look ugly or terrible all day long on the internet, and then you wonder why, I might defend myself is because it's my life's work. If you say, wow, that just looks like the ugliest thing I've ever seen, which I've heard hundreds and, well, probably thousands of times, it's my life's work. If your life's work were performing and I said it sounded terrible, you probably wouldn't take that nicely. Now, at the same time, I don't just get on there and say, oh, you're mean. I usually say, well, what is it you don't like about it? What is so ugly about it? I want to have a conversation so I can better improve the product and make it look nicer. But I know as well as anybody, there's no way I'm going to design something that makes everybody happy. Bach didn't do that. Yamaha didn't do that. Monet didn't do it. Nobody's done it. That's why we have all the different car companies and different phone companies, and people build different types of houses and drive different cars and wear different shoes. There's no one thing that's going to please everyone, and my goal has never been to please everyone. It's to please the customer that's right in front of me. That's my goal. It's always been my goal. When you are right here in my space, then I focus on you and nothing else, and that's probably why some people think that I don't care about them, is because the truth is, unless you walk in and want to work with me, I'm not focused on you. It's not that I don't care about you, it's just that I'm focused on the person in front of me because I want to help them become a better player. And that, my friends, is how you do great work and devote decades of your life doing great work and trying to push the limits. And then the public opinion a lot of times is against you. That's how it happens. It happens to a lot of people. It happened to Dave Monet, unfortunately. He's a brilliant guy. And it happened to Bach and Schilke. And the reality is, to do this kind of work, you have to have thick skin and you have to try new things. You have to try something that nobody's ever done. I'm going to show you this lead pipe up close. This is the first generation for the Bravura. I'll explain it, and then we're going to move on to the second and third generations. And it looks like the third generation is the final generation. I hope so, because we had a bunch printed. They're not inexpensive to have printed, and if all goes as planned, then we will start putting these into production this week. So let's look at this one closely. Okay, so first off, you can see I have a receiver here. That receiver gets soldered on, and it's not soldered yet. It's just designed to fit perfectly. So that will be soldered on with silver solder. There's a hole here and another hole here. I'll explain those in a minute. The Bravura logo is right here. And this one you can see was the first generation. I had this printed on kind of a mid-level machine, not a high-end machine, and it doesn't look great in my opinion. And I'll point out some things about it here in a minute. You can see I have this boss, which is essentially something that fits into a slot, and that's part of the design that's important. And then I have this other boss that has these holes in it, and that is to fit a finger ring that's adjustable for your pinky. So this would actually be held this way, and I'll show you a more recent version. This is on the brace, the lead pipe brace, so these would be your pistons. So that's kind of what we're looking at here. I have this thicker area. You can see that's 2025 1B. So this is actually the second generation, not the first. And then you have a section that holds the female tube for the tuning slide. And if you look closely, the print isn't bad. It's actually like geometrically fairly accurate. But let's go to the second generation. And that is this one. This was printed on a higher end machine, not the highest, but better. And you can see this is 4A, so this is actually the fourth generation. We skipped a few. I have some ridges on here, and those were specifically put on there to make the 3D print more stable. However, we found a way to remove them. In order to put a receiver on this, I'd actually have to grind down those ridges before I can put the receiver on. And that series was, again, a prototype. This has changed a little bit because we changed the fingering. And now you see the boss that fits in the slot is much cleaner. It's much more accurate. This one is extremely accurate. So because it was printed on a better machine and we spent more money on it, and the operator probably did a better job as well, then this one is geometrically very, very accurate. In fact, this one's probably accurate to within about 0.02 of an inch of the original design. The surface finish is very fine. If I wanted to sand that, I could. However, we have no plans to do that. The Bravura was designed to save money in the process. and sanding just takes more time. So through these little windows, you can see that's what the final finish will look like. Because it's stainless steel, as 316L, it's not going to rust, and it's not going to corrode. Or I would say if you could get it to corrode, you're probably putting it in a very harsh acid, because it was designed to be non-corrosive. And it's highly unlikely that even after 100 or even hundreds of years of use, that your saliva and your body chemistry is going to effectively wear any part of this lead pipe. And that is one of the biggest advantages that I rarely talk about with using these materials, but you're not going to harm this lead pipe. Now, you've heard of red rot, where the brass eventually has the zinc leached out of it because of acids in your hands or in your saliva or something else, or sometimes it's just something else in the environment. It could even be just having too many chem cleans. That red rot, what happens is the zinc gets leached out of the brass, and then you're just left with mostly copper and lead, and it becomes brittle and it falls apart. That is not going to happen to this. This is a lead pipe that's going to be around for thousands of years. And after the trumpet has been destroyed and thrown out, and eventually in an antique shop, and then after that hang on the wall, and 100 years later thrown in the dump, and then 1,000 years later dug up by somebody else, it probably will still look just like this. Very likely. It's not going anywhere, because it's a type of alloy that's not going to degrade. So that's the stainless steel lead pipe. I said the 4th generation. I'll show you the latest one. This is the 5th generation, and this one was printed on a high-end machine. It cost more. So I prototyped the first ones in less expensive modes, and then I moved up, and now this is the most accurate. And the design itself has changed, so things fit differently, because with that we also have changed this brace and all the pieces that work with it. So as we move on to this one, we can see this is 2025 5C. That's the 5th generation. 5th generation, and it's the 3rd variation of the variation. There's the Bravura logo. Now we've moved it down to just 3 holes. We decided, well, you don't really need to move that pinky ring or hook very much, so that's how much you get to move it, and we reduced the size of that from the original. Let's hold up the original. So you can see these two next to each other. So you can see we've changed some things, and we put this kind of a ridge on the top, so we have a T-slot on the pinky hook or ring, and that just makes sure it's extra secure. Look at the roundness, and look, you can see straight through that. The accuracy on this one is closer to 1/1000th of an inch. To put that into perspective, the CNC machines, my CNC lathe, if I'm turning things, then I could get down to sometimes 2 10,000ths of an inch tolerance. That's difficult because that machine is only a few $100,000. It's not like, a $500,000 machine. And because it's not less expensive, but it's a medium-high model of lathe. Because it can hold really tight tolerances, but I have to control the environment a lot. In other words, the room has to be the perfect temperature. And if inside the machine things start to change in temperature, then the tolerances start to slip to 3 or 4 10,000ths of an inch. That's really, really tight tolerance. However, if you were to machine all these features and not just turn it, right? Or if I were turning this long length, the shorter the part I turn on the lathe, the more accurate it can be. When it becomes this long, I actually probably would struggle to get the accuracy without all of these features, just with a tapered lead pipe on the lathe. And like I said, the lathe normally could hold 2/10ths on a short part. When it gets to a long part like this, it may hold 2/1000ths or 10 times less tolerance. Whereas this is around 1/1000th tolerance all the way through. So overall, better accuracy. And if I were to mill all of these features on that machine, which that machine can do that, that machine could actually make all of this. The thing is, it would take a very long time. The tolerances wouldn't be as tight, and I would struggle to do it. It'd be very difficult. And to make design changes would require me to reprogram everything. It would take probably 5 to 10 times longer to prototype all of this on that machine than to laser sinter it or 3D metal print it like I'm doing now. So all that to say, because I had this printed on a better machine, then it's more accurate. Now, take that one step further. We are looking at possibly purchasing a machine that is a laser sintering metal 3D printer. When I say laser sintering, what that means is that there's this box of powder inside the machine, and the machine is filled with nitrogen or argon. In other words, an inert gas to purge all the oxygen out of the build chamber. And a fiber laser actually goes down and it melts whatever pattern into the powder. And after it's done melting it, it lowers the powder bed a little bit, it lays more on the top, and it melts another layer to the previous layer. And this was built like this. Is actually set down here. And this layer was built first, and then it centered it, and it layered more, and centered and layered, and it just, the powder box kept going down and down and down until it got to this layer, and then it was done. And then this was attached to a plate. And that plate was put into a special machine that uses a wire EDM to cut this off. And then you finish it and you're done. Excuse me. So all of that to say, it's still quite the process to make one of these, but more accurate and better than doing it on something like the CNC lathe. And the nice thing is all the features are perfectly accurate, and it can go with the rest of the design. The way we save money with this is to print it in-house, which we cannot do yet. Like I said, we're looking at a machine. The machine we're looking at can print it and it can mill it. It's actually, as far as I know, in this steel that we're looking at, in stainless steel, it's the only machine that can laser sinter and machine the part in the same process. So in other words, it prints a layer by laser sintering it, and then it does that several times, and let's say it's done 30 or 40 thousandths of layers, then it will actually turn on the milling machine, and the milling machine will come down and remachine the part. So this could actually be a perfect finish on most of the features if we had that kind of a machine. And that could open up more possibilities to making valve casings, bells, of course the tuning slides and the lead pipes. I should have brought a tuning slide and some of the other parts over here, but we do actually laser sinter those now. If we had the machine in-house, we could do, excuse me, we could do much more, because I would learn the process, I get really good at it, and then we could do this even better. So that is the laser sintered lead pipe. These are the 3 prototypes I brought over here, and I thought there were 3 generations. I've been so deep in this, I was wrong, there's 5. Now, all of those progressively got more accurate, but I want to show you something that's actually more accurate than that. A couple years ago, I started prototyping the mouthpieces, and I wanted them sintered in steel and titanium and aluminum. Some of you own one of these, some of you have seen them. This was the original body for the Spectratone red mouthpiece, and these were laser sintered as well, and they're also CNC machines. So there's a CNC machined brass insert inside the skeleton, and over top of that is a 3D printed nylon sleeve. And all of this prototyping and this campaign, we had a Kickstarter campaign for this, and we launched it a year or 2 ago. That was in preparation for the Bravura trumpet. So all of this was the beginning of the prototyping for the trumpet. Let me show you this. So this one's really cool because you can see some of the build supports still inside there. Look at the tiny features. And if you see those really thin vertical lines, like right on this side, on the left, those tiny vertical lines are little tiny supports that I never pushed out. They're thinner than a hair, and I can just push them out with pretty much anything because they're so thin, even though they're stainless steel. And you can see this one still has the supports. I'm showing this one because I never pulled the supports out. See the little supports in there too. And then the inside is brass. And this is lighter and more efficient than the solid brass version we offered before. And the reason we made them from solid brass was, again, because of standing wave efficiency principles. The goal was to prevent this from ever letting the antinode from setting the body into motion, because if it did, the amount of energy in the sound wave would be reduced, and that equates to you having a harder time playing soft or a harder time playing wide intervals. And on almost all trumpets, the higher you go, the more antinodes you stack up, and you'll experience more energy transfer, which means higher notes are much more difficult. And on a Harrelson trumpet, if you've owned one or if you had time to play one, you know that the higher you go, the easier it feels, and that's simply because we have mitigated that issue so much that the energy rating is very, very high. So that is a combination of laser sintering steel and nylon. Now, let's get on to nylon itself. Remember, the reason I'm doing this video is to really be transparent about all of this. A lot of times people tell me that there's some kind of secrecy here and that we're selling some kind of voodoo. And the reality is everything is transparent. I show you everything I do. The reason I can confidently do that is because I have engineered all these things for so many years. I know exactly how they work and why they work, but I'm not concerned that someone's going to copy it tomorrow. However, I guarantee you, you're going to see people doing exactly what I'm doing in a few years. They're going to catch on and say, wow, we should probably do that. And I know that the big companies, Bach and Yamaha and any others out there that are making the same thing over and over and over again, they're going to be the slowest to change. And that's fine. I don't really care. I'm not competing with Bach or Yamaha. I love Bach and Yamaha. I love all the companies that build trumpets, and I love all the individual people that build trumpets. I think that anyone who puts their time and energy and they have passion for making music, those people deserve my respect. And I personally love listening to music. I love listening to them, and I love playing their instruments. And I have a massive collection of instruments. So if you go to my home or you go to my showroom, you're not going to see that everything's a Harrelson. There's a whole wall of other stuff, and I collect and play everything. I've owned almost every horn out there, and there have only been a couple I didn't like. So I'm being transparent, one, because I want you to understand how it works, and two, because I'm encouraging those of you who want to be trumpet builders, or those of you who are doing it, or even the big companies, if you want to figure out how to do it better and faster, hey, I'm happy to consult with you and teach you how to do these things, because I've spent my lifetime doing it. So this is the nylon bell brace, and that is what holds the bell on right here. And if you look at this, the bell cannot move. The bell is locked in there perfectly. That's because the taper of the bell was scanned and measured, and then I designed the brace itself to be the exact same size. And we had to put that bell on by sliding the bell further this way so that the thinner part would snap into here without breaking the brace, and then we slid it back to be tight, and it's all perfectly designed to fit exact. So let me hold it up close so you can see the actual trumpet and then just the brace. See what I'm talking about there? So these are the exact same brace, and that bell would fit in here. Now, one challenge I have is if I want a different bell to fit on the bravura, then this has to change. I need the dimensions of the other bell. In fact, all of our CNC machine trumpets over all the years had the same challenge. If I wanted to put a different bell on a brace, then I had to actually machine things differently to make all the dimensions fit, because each bell taper changes the dimensions, and that is an important component. It's one of those things that we do but you don't see, and it takes a lot of time. The only trumpet that doesn't have that issue is the Muse, because the Muse you can screw the bells on and off, and then we just had to have two consistent contact points, and then make lots of interface pieces to make that work. Regardless of how you do it, as soon as you change a dimension of a part on our trumpets, then you have to make a new part and design a new part. Now this fits perfectly against the valve casing. And again, you can see my model number in there. The generation on this one was 2C1X. The 1X is the bell, so that's the bell that it fits. And actually that fits the 1 bell and the 1X bell because they have the same taper. This is second generation and the third variation of that generation. And I've got 1.100 in there, and that is a special number to designate basically the hole patterns on this. This is a solid piece of nylon. If we look closely in here, let me see if I can zoom in. Yeah, you can see there's little tiny boxes inside there all over the place. And then you've got these holes. All of those are intentional. So these holes actually allow the brace to be screwed directly into the valve casing. And then these two and these two, the two bottom ones and the two on the left and right, those screw to the opposing side, or in other words, the lead pipe side. So if I were to take the lead pipe side, which is right here, and put these together, then they look like that, and you can see it's a perfect fit. And then the holes would go straight through. So see that? Now, one of the criticisms that I've had of 3D printing, and that I've heard many times, especially recently, because we just launched the Bravura on Kickstarter, I saw on Reddit lots of people saying, well, 3D printing could never be good enough to build a trumpet or to build these precision parts, because 3D printing is nowhere near good enough to do that. Well, this was printed with selective laser sintering, and SLS is what it's called. SLS printing is a little different than the printers that you have at home. If you have a 3D printer that uses filament that comes out, or even a resin printer, those are going to be much less accurate than something like this. And that's because this was made with the original additive manufacturing technology, again, which was laser sintering. It's the same technology that we used for the lead pipe in steel. The difference is we used it in nylon. Different machine, different parameters, and different, similar laser, but different laser. A lot of differences, but the principles are the same. These were both built in powder beds that were sintered together, and the part grew. The part fell into the machine further and further and grew as it sintered up and up. And that is extremely accurate. Now, this was printed on a high-end SLS machine. However, there's even a better technology than this. It's called MFJ, Multi-Fusion Jet, which is by HP. And HP is the company that makes the printers that are in your office and in your home. And they had the idea that they could print nylon. This is PA12. We're using PA12 for a lot of the parts and PA11 for others. I'll show you those. I should have mentioned it'll be a long video, so I know if you have to watch it in 2 parts or you never get through it, at least you got this far. But those types of nylon are extremely strong, extremely durable. And one of the big concerns that several people have asked me about was, well, if it's made out of plastic, it's just going to melt or break. Well, nylon is extremely strong. The thickness is as thin as I can make it while still maintaining a lot of strength. So the amount of surface area that holds the bell on this is, I don't remember how many square inches it was, maybe 10 or 12 square inches. It's a lot. A regular brace, a lot of times, the brace that's on a standard trumpet is typically less than half of a square inch of contact. The reason that matters is, again, because of efficiency, but also strength and durability. On our Muse trumpet, the part that holds the bell is very minimal, but that's because we want it to resonate more. And on the Summit series, it typically was probably around a square inch, maybe a little more. So maybe double what you'd find on a standard trumpet. This is much more, and that's simply because I want to utilize this material. I don't want it to ever break or have a problem. And I want it to be lightweight, and this is extremely light. Even though it looks big and bulky, it weighs less than the lead pipe. Probably half the weight of that lead pipe, which is in steel. The other concern that I have seen again and again is that it could deform with heat. People have asked me, well, at what point will this start to deform? Well, I've researched it quite a bit. I haven't put it in the oven to find the exact temperature. I'll probably do that later in the month after I have more Bravura trumpets built. But from what I can tell, it looks like the actual deformation temperature is around 340 to 350 degrees Fahrenheit, which means it's very unlikely you're going to get your trumpet that hot. If you leave your trumpet in the car, one person asked about that, would it deform? Well, I highly doubt it. I guess it really depends on how irresponsible you are with your trumpet, but I doubt it. I think if you measure inside a car, unless you had all the windows up on the hottest day and you left it that way all day long, I don't think it's going to get to those temperatures. I don't actually know the real temperatures it gets to, but I would doubt it gets above 200 to 250. And you shouldn't be doing that anyhow. And if you are going to leave your trumpet somewhere, well, then you should probably have a tracking device on it, like on the Bravura, and maybe keep it in your trunk where it's out of sight. But if you had it in a case in your car, then I'm sure that the temperature is not going to get as hot. And it'd be interesting to know if anyone has the answer to this. But I am certain that you're not going to have enough heat to deform this in regular use anywhere. I mean, when would you ever have a trumpet that even got to 200 degrees? You know, we're looking at what 212 is boiling. So yeah, you could boil these parts. I've done it. We actually dyed these parts in an Instant Pot. So it was in a pressure cooker, and it certainly was over 200 degrees to do that. And that pressure cooker it basically pressed all of the dye into it, because the nylon on this part was actually white. And again, we are looking at purchasing a printer that can do this work, but in full color. So HP makes a printer that can essentially, you can map whatever kind of design you want on the part, and it'll print the pigment inside the part. So we're considering doing that so that you wouldn't just have a black trumpet. Personally, I would like to see it in the same color brass, just to see what that would look like if it all blended together. That might be cool. Or make it a bronze. But I know a lot of people would be into, you know, doing, you know, a pink camouflage or something, or maybe your school colors, or maybe your school logo, or whatever you want to do. That may become a possibility. Now, that's where things start to get to the point where you say, oh, well, that's you look at it and say, well, that's a toy. But this is a real playing instrument that just would have some cool bling if you wanted to do that. Now, the black has really grown on me. When I first made the nylon and I had it in white, I thought that was terrible, but it was just for prototyping. And then I started making them in black, and I didn't really like it. For the first couple months, I didn't have this, and I didn't have the finger ring yet, and I didn't have this, which I'll talk about, and these were different, but basically some of this was the same. When I started that, I hated the black nylon. I hated the nylon period. I thought, man, am I going down the wrong road here? Is this a good idea, or am I just wasting my time and we're going to develop something that nobody will want? And again and again and again, I would come into the shop in the morning and I'd play the bravura so I could, you know, be familiar with it and get good at it and check it out and have all the parts on my desk and look at them. And I thought, man, that black nylon just looks so weird. Like, nobody's ever going to want this. And after a couple months, one day I walked in and I was playing the bravura and I set it down and I thought, man, that's such a cool horn. And I looked at it and I thought, I just love the look of this horn. And I realized something changed in me. Something about seeing this horn day after day after day, it clicked. And then I was like, actually, that's really cool. I cannot explain it, but I know this is a psychological phenomenon that happens to everybody, really. You see a new car on the road and you're like, that's the ugliest car I've ever seen. Then a few years later, you find yourself buying the exact same car. And I mean, the reality is that's how new ideas come into our world. They come in as almost like some kind of distress and distaste, and you think, why would anybody have done that? And on Facebook, I posted this, and I had several people say, why would you design such an ugly trumpet? They said ugly AF, if you know what that means. And numerous people said that, to the point where the whole post was becoming very, very negative. And I thought to myself, you know, I spent years working on this, and I somewhat agree with you. And I told people this. I said, you know what? I actually thought the same thing. When I first started working on it, I thought it was terrible. But I also thought, why is it that people on social media like Facebook or Reddit or other places, why do they feel, one, the need, and two, the privilege to just be mean? You know, it's unnecessary. Like, I did work really hard on this. And again, I go back to that example. If you worked really hard on something and you shared it with me, man, I would just praise you, because I would be so excited for you that you did something that was new or different or challenging for you, and you had some kind of reward. You had the end product in your hand. To me, like, I'm the biggest cheerleader for people that are trying to grow. And it's interesting how it seems like half the population is like that, and the other half is like, oh, I hate everything you do. And it's like, well, you're never going to win those people over, and I'm not going to waste any time on it. But I will say this. If you say it's ugly, it's probably not going to offend me. I don't really care. I actually thought it was ugly too. So we're in the same boat. The thing is, it grew on me, and now I'm starting to love it. And I'm excited to maybe print these parts in other colors. So the nylon, is it accurate? When I print it, is this part the right size? Well, it is. And the reason I know is because I can measure it. And we'll actually, in our production process, we'll have our portable CMM set up so we can actually measure the parts before they go on the production line, even though there's only 3 of us on the production line. But they'll go on the production line, so we'll be inspecting specific things because there is the off chance that something could go wrong with this, especially if we print them SLS. But we're planning on bringing that MJF printer, or MFJ printer, multi-fusion jet printer, the color one, into the shop if we can afford it. And in that case, it's less likely, but we'll still inspect the parts because we don't want a part to get on the line or on my bench and go to put it together and find we have a major issue and have to go back and make it again, especially if we printed something custom for you, a color or a design or whatever. So that's what you have to look forward to in the future. Now with this Kickstarter that we have going here in the month of May, it's May in 2025, we will not have any color parts offered in this. Just know I'm mentioning things that will happen someday or could happen, and they might not happen, it depends. But if we get enough people on board with the first generation here, then most likely it will happen in the next generation. And if that happens, the price point is affordable enough that you could sell your bravura probably for a profit if you're getting them on Kickstarter, because the price is so much lower, and then pick up the new one, when we release it maybe in 6 months or a year. So yeah, it's very, very accurate. I'll show you a couple other pieces so you can see some of the accuracy, and then we'll wrap it up. So the bell crook itself, this is one of the hardest ones. This one was an SLS print, and you can see a little bit of print lines there because I didn't spend a lot on this print. This is actually 2 halves like that, and these pieces snap right over top of the bell, and once they're snapped on, we use an RTV silicone, pretty much the strongest one that's available, and the snapping action actually holds it in place on the bell crook, so then it would be a permanent thing on your bell crook. However, with the RTV silicone in there, it fills tiny little spaces and gives a little bit of bumper, like impact resistance. But this kind of thing, when it's on your bell, is going to resist dinging and denting and damaging your horn. And then that was the 3rd generation, I think, because we have one that's weird looking. Well, that one's kind of weird looking too. But this is the next generation. And this one is the same type of design, except it has these stainless steel clips on it. And these stainless steel clips were 3D printed. So check it out. Look at the accuracy of these. See that? Now, those clips were modeled to fit exactly in the grooves that are basically the opposite. There's cutouts inside the design of the nylon where these fit. And this was printed on one type of machine and the nylon was on another. And we snapped them directly on and everything held fine. There's no RTV silicone holding this. There's no movement. There's nothing. It's perfect. And well, it's kind of a miracle to get it designed that well, especially considering a bell is kind of an organic shape, to model that and get it all right. But yeah, this is the end product. So if you're looking at the extreme protection variation on the bravura, where it adds this, and it doesn't add this tuning slide, it adds one of these to the tuning slide. It looks more like this one. And we don't have photos of it yet, but I'll have them in a couple days, probably tomorrow. But anyhow, if you add the extreme protection where you're trying not to damage these parts anymore, let's say you're just playing a lot of gigs. I have tons of clients who play in bars and in big venues like concert halls, or a lot of times arenas, right? And you're playing in areas where things can get a little bit rough. There's lots of sound equipment and the stage is very active. There's dancers, there's other people. I have hundreds of clients who play on our trumpets that play in those gigs all around the world. And a lot of people ask me, well, who are these people? I've never seen a professional trumpet player on your horns. And I'll be like, well, just look at my Instagram or look at my Facebook or look at YouTube. And people say again and again, well, I don't see it. I don't see anything. And I'm like, okay. What I think most people are used to seeing is the Yamaha or Bach list of artists. Like, hey, here's all the artists. Well, I don't put anybody into any kind of agreement to be an artist. If you like our horns, you play them, you share it. That's how I work. I don't see that having people listed on my website as important as other companies, and partially because I've always had too many orders and too much work with the people right in front of me to try to bring in hundreds or thousands of orders. I'm not going to build giant factories to build lots of trumpets. We expect to build 200 to 300 Bravura trumpets a year in the future. It's not a huge number. Believe it or not, 3 of us can handle that quantity. We'll still be making the Summit line and the Muse line, which are more intensive, and it shouldn't really disrupt anything. Because of the design, because of the way I engineered it, it can go together with better engineering and less actual labor. And that's one of the goals here. To bring the cost down, we have to bring the labor down, and that's what we've done with this design. But when it comes to the performers that are playing on our equipment, a ton of the best performers are live musicians that are playing arenas or different live events. And if you look at my Instagram, you'll see this. Actually, if you're watching this and you're one of those artists and you don't tag me on Instagram, nobody will see you on my page. So if you could tag me, that'd be great. And then I'll share your content in my stories and all that other stuff. But I see all these photos and I talk to all these people who are playing these gigs. Like, one guy plays for Cirque du Soleil, another guy is like in Poland and they do these massive shows. I've got dozens of people in Europe that just play these circuits where they're playing huge arenas. And it's the kind of music that we're not exposed to in the United States or in North America. But remember, we're just one little part of the world. The whole world is massive. There's all these different people playing different types of music. It's out there. And they're playing on, a lot of them, the original Bravura, the one that was from, what year was that? 15 plus years ago. I had the original Bravura. And that's actually the favorite model of a lot of these performers in Europe and South America, which is one of the reasons I went for the extreme durability package and the 3D printing, and it had to be very accurate to be able to do that. So that's why this exists and the version on the tuning slide exists, and I created the tracking for those people as well, because sometimes their horns are stolen or misplaced, or they get put on a plane or a bus and they don't know where they are. And this is just a peace of mind. There's a tracking device in here and you can just look it up on your phone. So yeah, getting back to the 3D printing of these parts, it's extremely accurate. And that's why I offer this, is because there are people, like thousands of people, who are playing gigs where things could get damaged easily. It may not be you at home. I've had lots of people who have said, well, the market for this would be marching. That could be true, especially if we do them in color. You could have it printed with whatever colors you want. So maybe that's a direction we will go. The consumers will really drive that more than I will. But that is what the 3D printing capabilities look like today. And the accuracy and the repeatability and the quality are so much better than they were in the past. And now I'm eating my own words because I used to be so anti 3D printing. Not anti, but anti applying it to precise things. Now I'm eating my words saying, well, the technology has come a long ways. And, at the end of the day, this is a technology that's so new, most people are not putting it into their production products. There are very few companies that do. The ones that I've seen that do have been Ferrari and Lamborghini and Jaguar and Lotus, a lot of the sports cars companies, and of course a lot of the F1 racers are doing 3D printed stuff, both in metal and in nylon and other materials as well. But I would say that titanium and stainless steel and nylon are the big three where most of the money and most of the best machines have been put into right now, most of the research. So they're the best, I guess, quality that's in use today. Copper and brass are almost non-existent. There are bronzes and pure coppers that you can have 3D printed, but I've researched far and wide to find companies that can print those things for me, and they're all completely booked for years with aerospace work. And because of that, we can't even get a tuning slide or a bell or a lead pipe printed in those materials because basically Department of Defense and other kinds of contracts are taking up that space, and probably all the rockets that are being launched. So, because a lot of them make rocket engines. I'll show you a couple of the parts because they're sitting here and I meant to show you. This one is the exact same lead pipe brace you saw before, except this one is dyed green. And actually we tried to dye it a brass color and it came out green. It's exactly like the one you saw before. This is one of our finger rings. They're modular and they're adjustable, and you just tighten one little screw here wherever you want it to be. But this one would be for the third slide, and it's got a little split design to it so it can squeeze together. See that? And this one's dyed in red. I did that one just to show off the red, but also because the black ones are so hard to see. If you look at a black one, here's a black one. Well, this one's a little easier in this light, but a lot of times I photograph them and it's really, see how hard it is to see the features. So, and there's the thumb ring, which again just requires one screw. And the pinky ring, this is actually an old generation. That had 2 screws, the new ones actually just have 1. And I'll show you the new generation. It's right here. So this is the new pinky ring. This is the one that fits on that T slot. So that goes on this lead pipe. So let me hold that up. This lead pipe, that would slide right on there. And you can see they're the same profile. So this would allow you to adjust the distance on the pinky, and again, just with 1 screw. And this one is a thumb ring, same thing. You just have 1 screw to adjust it. And these 2 are in stainless steel. So you can upgrade and get stainless steel, and we'll be offering, different types of material. But if you want the most robust version, you're never going to break this. You could whack this with a hammer 50 times, and it might not even show any marks, actually, because it's so strong. Because 316 is extremely strong and durable. So that's what I wanted to share today. I know there's a lot happening with the Bravura release and the Kickstarter. If you made it to this far in the video, the Kickstarter is running, and you can save a lot by just backing the Kickstarter. If you have never done Kickstarter before, give us a call and we'll walk you through it or help you however we can. Our number is 303-657-2747. We are holding regular weekly open houses at Harrelson Trumpets here in Denver for you to come in and play the Bravura through the month of May. And we will have the Bravura with us when we go to the ITG, which is at the end of this month. And if you are a vendor that is showing at the ITG and you want to have a Bravura on your table to show off, just contact me and I'll loan you one for the show. It'll get people interested in going to your table, strike up a conversation, and it doesn't matter if you sell sheet music or if you sell trumpets or if you're a retailer or even if you're just, anyone who shows anything at the ITG. If you want one on your table, I'm happy to share one with you. I'm not showing at the ITG. We don't do that anymore. We just have too many things going on. I need to spend my time with my customers. Again, the people in front of me are the most important. And also, the development of all these things takes a lot of time. So it's been years since I've gone to the ITG as a vendor, but I will be there doing interviews with trumpet makers and trumpet players for my Rumors and Dreams series. And if you want to be interviewed or if you want to suggest I interview someone, just let me know. Put it in the comments or email me or call me. And I'm happy to put people on the channel. I really love to interview other trumpet makers and other people that have devoted their time and energy to our craft, And I'm hoping to interview 1 or 2 mute makers this year. Last year I interviewed David Mahler, who makes natural trumpets, and that was a really fun interview. And I interviewed Terry Warburton, who obviously is a legend in the industry. And if you want to see either of those interviews, they're on my YouTube page. And I have like a dozen more interviews that are being released right now. So you'll see those as we lead up to the ITG. The last thing I was going to say is there is going to be a Bravura Ambassador program starting next week. That means that there will be a person in 10 different cities around the United States that has a Bravura in their hands that they'll let you try, and they'll probably hold a couple events where people can come try them, and you might even be able to borrow it for a day. We're setting all of that up right now. If you want to become a Bravura Ambassador, email me or call me. My email is harrelsontrumpets@gmail.com. And I would love to see you, showing off the horns. And if you decide this is something that really works well for you, it could be the horn, your next horn. But we're looking for Bravura ambassadors, and we have a long list of people that already want to be ambassadors. but this is the first time I'm putting it out there on YouTube that we're going to do this program. And really, that's mostly for those of you who may be in St. Louis or somewhere and you're like, oh, I want to go try one, and I can hook you up with the person to talk to. So thank you again for watching. Thank you for listening to my long explanations on 3D printing and the accuracy and the consistency and reliability and strength. That was the purpose of this video. And that is why I chose these materials and these processes for the Bravura, because at the end of the day, if we bring those machines in-house, the price comes way down, and then we can afford to sell them you know, at a lower price than you're going to find other Pro horns, and we're going to have more resonance and more efficiency. So thank you. I'll see you guys next time.